Hi everyone, so in this video I'm going to go over graphing the tangent function. So we're going to learn how to graph it and plot it on the xy axes, and then we're also going to know how it behaves and how it's different from sine and cosine. The first thing I want to review with you guys is that you should know that tangent of theta is equivalent to sine of theta over cos of theta. This is really important because since this is what tangent's equal to, we need to be careful because if this is a fraction, we have to be aware that cosine of theta could never equal 0, because if cosine of theta was 0, it would make the whole tangent graph become undefined. It is undefined when cosine of theta equals 0. So we always want to make sure that we know where cosine is 0 so that we know where tangent cannot exist. And what will help us is the unit circle. So if you remember, x is cosine and y is sine. So what I'm going to look for right now is I'm looking for the x values where cosine is 0. So I want to know where x would equal 0, because therefore that would make tangent undefined. And that happens right here and right here. So this is 0 degrees, 90 degrees, 180, 270, and back to 360. In radians, we can change this to 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the places where tangent will be undefined is at pi over 2 and 3 pi over 2. So therefore, tangent of theta is undefined at pi over 2 and 3 pi over 2. Because if you were to do the full thing out, and if you were to actually do the value of tangent at pi over 2, it would turn into sine of pi over 2 over cos of pi over 2. And when you type in sine of pi over 2, as long as you're in radians, you're going to get 1. And when you type in cos of pi over 2, you'll get 0, which makes this fraction undefined. And the same thing will happen if you change this to 3 pi over 2. The only thing that would be different with 3 pi over 2 is that this would become negative 1, because on the unit circle, 3 pi over 2 is at the bottom. Okay? So what does this do to our graph? Well, basically, anything that's undefined on a graph is described with something called an asymptote. So if you guys can look at this graph, this is the graph of tangent. And you can see that there are dotted lines here that represents our asymptotes. These are asymptotes. And these asymptotes for tangent occur at values of pi over 2, specifically odd values of pi over 2. And if you can visualize this, the next one would happen at 5 pi over 2. And then after that, it would happen at 7 pi over 2. So it's going to continue the pattern, and it's also going to continue this shape. So if you continued it, there would be something here, and then it would continue the same shape here, and so on and so forth. It is still an infinite graph from left to right, but we want to be careful because at these values where we see these dotted lines, there are asymptotes, and this is because this is where cosine is 0, which will make the tangent function have undefined values. Therefore, we cannot cross these values. Okay? So I'm going to show you in the next slide how to graph it on your own, and then we'll talk about some things like period, range, domain and range, and so on and so forth. So again, the most important thing about graphing a tangent function is that you know where the undefined values are. You can always find them if you put your calculator into radian mode and type these in. So tangent of 0 will give you 0. Tangent of pi over 2 will give you undefined values, so I'm going to put a u there. Tangent of pi will get you back to 0. 3 pi over 2 will get you, again, undefined, and then 2 pi will get you 0. You can graph this in your calculator if you choose to do so. they want your interval from 0 to 2 pi. Your x scaling, you can still do pi over 2 if you'd like. And then I'm going to do -4 to 4, because if you looked at the first slide, you could see that it shoots off infinitely up and down. So I'm going to make my tangent graph. So I'm going to cut this in half as neatly as possible. I think I can actually do that. Let's see if I can figure that out with this. Good. So this is going to be 0. This is going to be 2 pi. Halfway will be pi. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 3 pi over 2. 1, 2, 3, 4. Pi over 2. And we're doing 4 to -4. Now looking at the table, you should know that there are undefined values here and here. And we also know this because of what we discussed in the previous slide, because this is where cosine would be 0, and therefore, on the unit circle, I mean, and therefore tangent would be undefined. We also know that there are values at 0, pi, and 2 pi that cross the x-axis. And then we can kind of know that from the calculator, if you have this plugged into your calculator, you can visualize they're going to shoot this up towards this way. This is going to shoot down this way, shoot up that way, and shoot down this way. But there actually is a nice value in between 0 and pi over 2 that we can graph. And this is because on the unit circle, there's a point right here, and this point is 45 degrees. Now 45 degrees is special because it's from the 45, 45, 90 triangle. And in this case, the x and y values are the same, which means the cosine and sine values are the same. So at 45 degrees, or if you want to do it in radians, which is probably better because we always do things in radians when we graph, so in radians this would be pi over 4. This would be cosine of pi over 4 over cos of pi over 4. And because these are the same values, they're both radical 2 over 2, they reduce to 1. So this means that there is a nice point halfway in between at pi over 4 where the graph hits at 1. So we can go ahead and connect this and shoot it up towards the asymptote. And this will continue to happen in all the quadrants because remember we have a reference angle of 45 degrees in all 4 quadrants. It'll just be a little bit different because of who's positive and who's negative. In this quadrant you'll have negative x. So this means when you divide these two, you're going to end up getting -1. So in between here, I'm going to plot a point at -1. Down here, I'll have both of them be negative. So when you divide a negative by a negative, that'll result in a positive. So I'm going to plot a point of 1 over here and shoot up. And then in the bottom quadrant, this is going to be positive x and a negative y. And when you divide these two, you'll end up getting another -1. So we'll have a point of -1 here. Okay? So a few things to keep in mind when you're graphing this. Number one, you don't have to plot the asymptotes, but I do it because I want to make sure I don't cross this line, and if you do cross that line, you will get points off. Number two is that it is nice to plot these extra 1 and -1 points because it gives the graph more of a shape. Now also, you can label these just fine. This one is pi over 4. And we can label this one the next value. If this first one's pi over 4, that means all of these are counting by pi's over 4's. So if you think about it, pi over 4 would be here, 2 pi over 4 would be here, that reduces to 1/2. So this would be 3 pi over 4. So I can actually label that 3 pi over 4. This guy here will be 4 pi over 4. But when you have 4 pi over 4, the 4's would cancel, resulting in just pi. So then this would just be 5 pi over 4 if you wanted to label it. And then this would be 6 pi over 4, but that reduces to 3 over 2. And this would be 7 pi over 4. And lastly, 2 pi is 8 pi over 4, but again, 8 divided by 4 is that 2. So that's why we can label it this on the x-axis. It is also nice because you can type these values into your calculator. If you type in tangent pi over 4, you'll get 1. Tangent of pi over 2, undefined. Tangent of 3 pi over 4, you'll get -1. Tangent of pi, you'll get 0. Tangent of 5 pi over 4 will get you 1. Tangent of 3 pi over 2 will get you undefined. The calculator will give you an error if you type that in. Tangent of 7 pi over 4 will get you -1, and tangent of 2 pi will get you 0. So this is how you graph it. Again, you don't have to label all of these numbers on the x-axis, but most importantly, please make sure you label the 0, the 2 pi. Probably the pi would be a good idea as well. Now let's talk about period. Now the definition of period is how long it takes to make one full curve. This graph is very different from sine and cosine. It's very different because we see that it has this wave feature, but it's being blocked by these asymptotes. It's not a continuous curve. Continuous means that it will never break. This breaks, if you can see that there are 3 pieces on here. So the period for this function is how long it takes to make one full up and down wave motion, whatever you want to call this. And that is a distance from pi over 2 to 3 pi over 2. If you subtract that, you'll end up getting 2 pi over 2, and therefore the period for tangent is pi. So that's how long it takes to make one full curve. Now there's also domain and range we should talk about. The range in this graph is -infinity to infinity because it goes all the way down to the negative y's and then also shoots all the way up to the positive y's. The domain is where we have an issue. If you can see, the domain has breaks at 3 pi over 2 and at pi over 2 over here. And this happens at odd intervals of pi over 2. So the domain is going to be all reals, but x cannot be intervals of pi over 2. This is the fancy way you would write n pi plus n pi, because if you keep adding intervals of pi, you would keep increasing pi over 2. But the easiest way to write it is that x cannot be odd intervals of pi over 2, because that's where the graph is undefined, because that's where cosine is 0 in the tangent fraction. So I hope this helps you guys on how to graph tangent, and I'll see you soon.